Now that my AP has all these controllers, it knows all these IP addresses, which one should it join? And that's the join phase. The join algorithm is different from the discovery algorithm. Discovery is to find as many as we can. Join is to find the best one and join that one. So finding is easy. We just go through that list. And from the answers we got from those controllers, we're going to pick up one as being the best candidate for my access point. And the way you do it is that you can configure the access point and say, I want you to always join this controller if you get an answer from this one. And that's what we call the primary controller. You can also say, if this one doesn't answer, this is your secondary option and your tertiary option. So you can configure IP addresses and names of controllers that you want the AP to join in priority. So of course the AP will remember those IP addresses, and that's one of the memories of its past lives that the access point is going to try. And maybe we'll get answers from those, and maybe not. In any case, it's going to keep on building its list during the discovery phase. But then when it moves to the join phase, if any of those has replied, it's going to try to go to the primary first, say, can I join you? And if it doesn't get answer from the primary because it's not there or because the primary doesn't have any space left, then it's going to try the secondary if it had an answer from it, or the tertiary if it had an answer for it. So that's a sort of preference value, which doesn't make that it's going to succeed, right? We're going to try those if we got answer from them and if they have space for that access point. So for example, it could be primary is WC5 and secondary is WC7. So we're going to try primary first and then secondary. What if we didn't get the possibility to get to those primary, secondary, and tertiary controllers, either because we didn't get any reply from them trying to discover them, or either because we got an answer but they didn't have any space left, all their access point slots were used? Well, then there is a nice feature which is called the master controller mode. And what that does is that we say, if you don't make any configuration, the AP can end up anywhere on any controller. And to avoid that, you can configure an option in the controller which is called master. And when you do that, that controller is going to have a specific bit, a specific flag in its replies to the discovery messages from the access points. It's going to reply just like the others, saying, you send a discovery message, I am a controller, I am available. It's also going to mention, of course, like the others, these are the number of access points I can take, and these are the number of access points I already have, so the AP knows if there is a slot available or not. But what the master will have, and that the others will not have, is that checkbox saying, and I'm a master. And that means if you cannot go to your primary, or secondary, or tertiary, well, go to the master. So that avoids that the AP ends up anywhere. It goes to the one that is the master. Again, if it can get to the primary, it will go to the primary, or secondary, or tertiary. It will go to the master only if a master answers and the primary, secondary, tertiary are not possible. This is how you configure the master mode on the controller. You just go to the controller, and there is an option that is called master controller configuration. You just check that box, and that one controller is going to have that master flag in its replies. Of course, you configure only one controller as the master, right? But that's a nice way for you when you deploy access points to know where the access point is going to show up. If you have 15 controllers, you just set one as the master, and you know the APs, if they don't have any configuration, any primary, secondary, whatever, if they discover that master, they'll get there. That's a nice way to get those APs in and then maybe configure at that point, because they are new, don't have any configuration yet. So you get those APs and you configure the primary at that point and send them to the primary. That's a nice way to deploy networks. Okay, suppose we have a master replied. Fine, we'll join that one. But suppose we don't have a master that replied because there is no master, or we couldn't get any discovery response from a master. And of course, we don't have any primary, secondary, tertiary. Well, in that case, the last solution for the access point is to look at all the controllers and go to the controller that has most space left. I say the least loaded in terms of access point controllers. Least loaded is something specific. What does that mean, least loaded? That means that is the one that has the least lowest ratio of license to access points. In other words, if you have a 2504 that has a license for 50 access points, and it has today 25 access points, in its discovery response, this controller is going to say, I am a controller, I have 25 access points so far out of a 50 access point license. So that means that this controller has 50% load. But if there is another controller that replies, another model, say for example a 5508, that can have a license for 100 access points and that has 40 access points, which one of these two is the least loaded, do you think? Well, the answer is the 5508, because the 2504 as a 50% license load and the 5508 as a 40% license load. So the load is going to be a relative value of total possible amount of access points to today connected access points. So although the 5508 has 40 APs and the 2504 has 25, the 5508 has a 40% load and the 2504 has a 50% load. So the AP is going to choose the 5508 in that case. And that's again an SHN scenario. If it has a primary, it will go there. If it has a master without primary, secondary, tertiary, it will go to the master. It will go to the least loaded if there is no other specific choice that is left to the AP because there is no configuration or the primary, secondary, tertiary, or masters did not respond. Then at that point, the AP is going to choose the best controller based on all these criteria, and it's going to join the controller. And that's basically creating a DTLS secure tunnel over the 5046 UDP port, where the AP is going to secure its connection to the controller so that they have a secure way of communicating without anybody being able to eavesdrop or intercept this configuration dialog that is going to occur after that. So the join phase is primarily a choice phase, and then it's a DTLS tunnel.